Now, let's get a closer look.
The lymphatic system is an essential part of the immune system, and it consists of a network of lymphatic vessels, tissues, and organs. The lymphatic vessels drain interstitial fluid, or lymph, from peripheral tissues back into the blood. Lymphoid tissue and organs contain a lot of lymphocytes and other white blood cells. The primary lymphoid organs include the thymus and bone marrow. And the secondary lymphoid organs include the tonsils, lymph nodes, spleen, and mucosa-associated lymphoid tissue, or MALT for short. The thymus is a flat, encapsulated lymphoid organ located in the anterior superior mediastinum, right behind the sternum. During embryonic development, the thymus originates from the embryo's third pair of pharyngeal pouches. This organ is most active during childhood, reaching its largest size around puberty, with a weight of approximately 30 to 40 grams. After puberty, the thymus will start to slowly involute or decrease in size, with less lymphatic tissue and an increase in adipocytes. The thymus plays an important role in the maturation of T cells, which includes negative selection or central tolerance. This process, along with regulatory T cells, help prevent autoimmunity. This is a low-power image of a neonatal thymus. At this magnification, the thin collagenous capsule is a little hard to see, but if we zoom in a little further, we can see the capsule more clearly, as well as the connective tissue that extends inward from the capsule into the thymus, forming incomplete lobules. When compared to an adult thymus, we can see the adult thymus has noticeably more fatty infiltrate, which is seen by the white spaces scattered throughout the organ. The lobules of both adult and neonatal thymi have inner regions that stain light purple and pink, which is called the thymic medulla, and the outer regions of the lobules are more basophilic or dark purple, which represents the cortex of the thymus. The clear distinction between the inner medulla and the outer cortex of each lobe is typically more prominent in early childhood, similar to the image on the right of the neonatal thymus. If we look at the thymic cortex at high magnification, we see that the dark purple color of the cortex is mainly from densely packed and very basophilic T lymphoblasts, which are also called thymocytes. The thymocytes are supported by a network of finely branched epithelial reticular cells called thymic epithelial cells, or TECs for short. These cells have a pale cytoplasm, large oval nuclei, and cytoplasmic processes that can be seen weaving between the lymphoblasts. One of the important functions of the TECs in particular is their involvement in the formation of the blood-thymus barrier, which consists of TECs, parasites, and endothelial cells. The blood-thymus barrier is the selective barrier that separates the cortex from the blood, in order to prevent exposing the lymphoblasts to antigens that circulate in the blood. The TECs help form the blood-thymus barrier by joining themselves together with desmosomes and surrounding the microvasculature of the thymus. Moving to the lighter stained medulla, there are fewer lymphocytes than the cortex, which can still be partially seen in the upper left of this image. Compared to cortical lymphocytes, the lymphocytes of the medulla are more mature and don't stain as dark. The medulla also has a large abundance of thymic epithelial cells that also form large clusters of TECs called Hassel's corpuscles. These structures are unique to the thymus and are often arranged in concentric layers or lamellae. Newborn children will have Hassel's corpuscles, but they increase in number and size as individuals get older. Dendritic cells are also present within the medulla, but they're usually not easily identified in slides that were only stained with hematoxylin and eosin. Alright, as a quick recap. The thymus is a flat, encapsulated lymphoid organ located behind the sternum. It's most active during childhood and slowly involutes in adulthood, with fatty infiltrates and decreased thymic tissue. Each lobule has an outer cortex that's very basophilic and stains dark purple, whereas the inner medulla stains a lighter purple and pink color. The cortex consists of many basophilic T lymphoblasts that are supported by a meshwork of thymic epithelial cells, which have a pale cytoplasm and cytoplasmic processes. The inner medulla also has an abundance of TECs, but will also contain Hassel's corpuscles, which are the structures formed by closely packed and concentrically arranged TECs.